How you guys doing? All right, let's go back to this code. We're gonna learn this. We're gonna finish up all the problems of Hackerrank. This is gonna be awesome. Yeah, we're finishing this up. We only have 4 more problems left, and then we're done. So let's see if we could finish it today. I'll try abstract classes. Why not? Abstract classes can be used as base classes. Okay, yeah, sure. Okay, I don't care. Give an abstract class cache with member functions. MP, CP, tail, head, set, get. You have to write a class LRU cache which extends the cache and uses the member functions and variables implement in LRU cache. I don't even know what an LRU cache is. What does that even mean? What does it mean? LRU cache. So I'll extend. Okay. What am I doing? What do I have to do? I have a constructor. Okay, so let's just do like LRU cache. Capacity. Alright, I'll take in a capacity and then I set the capacity. I could call what can I call? Cap do this dot CP is equal to cap. What is this problem? Declared global namespace. What does that mean? Is an abstract. Let me make it virtual. Actually, that just doesn't make any sense. What is the problem here? Oh, unimplemented methods. Okay, sure. All right. Okay, what am I setting? What actually am I setting? Map the head of the node in the linked list. Get key. What is key? Key is a integer? What is it supposed to return? Oh, returns the node? Capacity. If the command is get, then what do? We get the key. Map the key to the node in the linked list. Does that mean return the node? What does a node have? Oh, it has a value. Okay. Okay, so what we do is we set like node current is going to equal to mpg, and then we return cur dot key, right? Key cur dot value. Okay. Set. What does set do? Set the key to the value. Okay, so we could do what we could do is we could create a new node. Node. And then we pass in, what is our key? What is this? Set. Okay, I'm gonna guess it's a key value here. This is value. So we're gonna set the key and the value for this. Yeah, in our new node. And then what we're gonna do is we're going to put this into this map. And how do we want to add to the linked list? I don't know. So we just do mp add key is going to equal to node. Okay, but then how do we set this though? Oh, is the key? Wait, what the hell does the key represent? Oh, okay. So if cur value is equal to negative, return -1. All right. What about the set? Let's see. Okay, so if we have mapped the key and then we set the node. Is that it? But we also need to loop through and add it, right? How do they want us to add it? Set or insert the value of the key. If it's present. Otherwise, add the key as the most recently used key. I think I should do if mp.count is at key is not equal to 0. Greater than 0. If it's present in the linked list. So we're going to loop through the linked list and check if this I don't know what they mean. Alright, we're gonna just do this for a few more minutes. I have to do homework though. Soon I gotta do homework. This is the only time I could live stream today. Sorry guys. Yeah, if I could live stream every day I would. Set or insert the value of the key if it's present, otherwise add the key as the most recently used key. If the cache has reached its capacity, it should replace the old key. Oh, if it's present. So if it's greater than 0, then we're just going to set it to equal to this. Oh. Ugh. Okay. I got it. We start from the beginning and then we're going to loop to the end. Alright. And then if it's like, we got the head, we're going to start from the head. I'm going to check, does head's key is equal to the value. This is hard. Man, this is hard. Man, we're gonna figure this out though. We're gonna freaking figure this out. I just don't know what they mean. Okay, I actually have no idea. What do they want us to write? I don't even know. What do they mean by this? Okay, yeah, I create a new node. If it's empty, we set the head, the tail to the node, and we set the key to it. Then we return. Okay, that makes sense. It's the fucking mouth is empty. Ugh. My god, I'm so exhausted. If the map is empty, we create the node. We're gonna create a node. We're just gonna call a new node key value, and then we're just gonna pass it into the fucking thing. Tail is equal to head is equal to new node. And we set map at key is going to equal to new node, and then we return. I believe that's what they said. Okay, otherwise, let's find the node. If it's not equal to the end, what the hell is going on? Okay, let's find the node, find the key. find the key. If we found the key, then we set our head we set our key to equal to the value. Head is equal to its second. Tail is going to equal to the previous. Man, this is really confusing. Otherwise, let's create a previous head KB. Is this if it's like size of 2? Man, this is crazy. Crazy. This shit's crazy. That shit is wild, man. Fucking wild. I'm so tired. So tired, so lazy. I'll see if I could do something. Okay, I don't understand. Okay, we find this, then we set the second one to equal to the value. Oh, this is just setting the pair. This is like saying map at, okay, so this is saying map at key is going to equal to value. Wait, what is value? What is V? What the hell is V? It at second. Oh my god. Okay. So this is like node current is going to equal to this. And then we set this current value is going to equal to V. That was so stupid. If the head is equal to the node we return, okay, so if the current head is equal to what? If the outside head? What the hell is head? What is head? Oh, here. Yeah, here. That head. Okay, so if it's is equal to head, we're going to return current dot head. If current is equal to head, oh. Otherwise, we do the map dot previous dot next is going to equal to its second next, maps next. Oh, I have no idea. just do the last part. What if it is equal to n? Like it doesn't exist. And what do? We create. What if it doesn't exist? We create a new node. Previous had kv. So we do node cur is going to equal to new node. Key value. Create our previous is going to equal to current. Well, head is going to equal to current. Map at key is going to equal to head. I felt mine in. Chat, no, I'm not graded. On. What if I finish PhD? Oh my god. Man, I just realized I was still recording. And I've been stuck on this way too much. Alright, let's go back to this. Alright, what are we doing? What are we doing? Oh my god. Okay, we have head to the previous point to n. We head point to n. Okay, so head previous point and cur. If it's greater than the capacity, we set the... Okay, so let's actually just copy this. Okay, so if it's greater than capacity, the question asked us to erase it. These questions are really poorly written. I don't know if it's on purpose that it's poorly written, but sure as hell it's poorly written. Because it's saying like if it has reached capacity, it should replace the least recently used key with a new key. What does that even mean? So in what they meant here is that if a size greater than capacity, what they mean is to set the tail to equal to the previous. Okay, so remove the last one. Erase, erase. Erase the tails next. Set the tails next to null. Erase the map. Okay. Okay, so that's that literally had no. You cannot get that from reading the question. That's a dumb question. This is a dumb problem. If the seconds previous next is equal. What? Okay, if the current is equal to the head, okay, so let's say let's say it's not equal to the end, so I found the node, okay, so I get the current node. So the current node's value is equal to the value. If it's equal to head, then I just return because I don't need to do anything. Otherwise, I'm going to set current's previous next is equal to current's next. Okay, so current's previous next. Current previous. Current, so I'm current, I go to previous, I go to next. So I set this, okay. Okay. This is just saying current's next is going to equal to current's next next. Whatever. Okay, if the tail is equal to the current's tail equal to previous. Okay. Yeah, you can't really get this from reading this. It's just a bad problem. Because you don't know what they're asking. If the tail is equal to the current, then we say current, the tail is going to equal to the previous. Okay, so that removes the last node. Otherwise, what are we doing? Current's next previous equals to current's previous. Current's next previous is equal to current's previous. Current's next previous Okay, so this is removing the current from the previous. Removing current. Current's next equal to the head. Current's next is going to equal to head. Current's previous is going to equal to null. Okay, so this is like removing the front of a linked list. Head's previous is going to equal to what? Head's previous is going to equal to current. Head is going to equal to current. What? Okay. I don't really understand why it's... Basically, they're just like removing linked lists. That's all they're doing. Like, it's not like... It's just a stupid problem. The problem's stupid. Let's try this. Maybe my get method's wrong. Oh, what the fuck? Nah, I'm losing. Oh my god. This is a dumb problem. I don't really want to do this problem, actually. If it's empty, okay, let's go back up. If it's empty, create a new node, set all to add, and return. Okay. Okay. Otherwise, we find the node. If it's empty, otherwise we find the node, create a new node, return. Okay. Otherwise, we find a node, find the node. Node's value is going to equal to value. If head is going to equal to current. You know what? Let's do this. Let's do this. Still wrong. What am I doing wrong? Oh, this is supposed to be outside. Yay. Okay. Basically what they're doing is they're just removing, like, this is a stupid problem. They're saying that when you want to set something, you're just going to remove the last node that it has if the capacity is greater. And if it's present, just replace it. If it's not, then we just add it to the map and the link list. So all this stuff, all this garbage here, this is just removing it. Removing the last tail. All this stuff is just literally removing the node from the map. Removing the node from the map or removing the value from the thing. So it has nothing to do with like, it's just removing like a linked list pretty much here. And removing it from the map. That's what it's doing. So there's not much, this problem is just stupid. Yeah, this problem's stupid. And you would not have been able to get this problem if you just read this. Because this doesn't really make any sense. You have to implement a class for the extends user method. Like, it sets a new value of the key if it's present, otherwise add the key as recently used key. Like, what does that even mean? And if the cache has recently reached its capacity, you should replace the least reused key with a new key. Like, what is that supposed to mean? That doesn't mean anything. Like, if you want to... Like, it's just stupid. This is a stupid problem. This whole problem's stupid. Alright, this whole problem. Alright, let's actually just try to just continue on the hard problem. We solved this. Let's see, we only have 3 problems left, so I don't think we could try to like just grind it out. Alright, what are we doing? Use the scrolls. Spend a few of the reading area and complete the body counter phone. Check the casting area. What are we doing? What are we doing? You must first identify what kind of spell you're dealing with. The wizard uses scrolls to conjure his spell. Sometimes uses some of the generic spells that restore stamina. In that case, you will be able to extract the name of the scroll from the spell. Then you will figure out how to assimilate this new spell to the spell formulas written in your spells journal. Complete the counter spell function. Check dynamic cast. How do you use dynamic cast? I haven't used this before. Oh, okay. So if we have like a base class and a derived class, you set this, you could actually cast base class down. You also cast to the side. Downcast from B to 1 successful. Downcast from B2 to 1. Okay, so we could cast downwards from derived to base. Derived. Actually, B2 is base. Downcast from base. From base to derived, I think. I don't know. Whatever, I don't care. What are we supposed to do? What are we supposed to do? What are we supposed to do? Counterspell? What does this mean? After identifying the spell, print its name and power. This is so stupid. Is this really like named correctly? What's the point of these LS? Wait, what's LCS? Longest common subsequence? Why is this the longest common subsequence? This literally has nothing to do with the problem. Okay, what are we doing? We're casting this spell downwards. What is spell currently? Use some of the generics restores. In that case, you extract the name of the scroll from the spell. Then you will use how similar this new spell is. The spell is formulated, and then there's time to journal special type rate. You're in the log code in your editor. Complete the body of the counter spell function. After identifying the given spell, print the name and power. Oh, okay. So like, where's the counter? When does counter get called? We created a spell. We cast it. And we pass the spell in. This is a spell. What does the spell have? It has a scroll name. But the scroll name is private. But you can reveal the scroll name. So I don't understand. Dynamic cast. Oh, okay. Okay. So if it's... Okay, so we're going to counter... We're going to cast this to... I understand now. We're going to cast the spell into... Yeah, like this. Okay, so... I understand. Okay, so we're going to cast a spell from... what is the original spell? So spell, we're going to cast a fireball. And if it works, then we're going to print out fireball. So derived is fireball. And this cast is from spell to fireball. Yeah, fireball. Then if it works, then we're going to do... I'm going to call reveal fireball. Alright, and then we're going to do the same thing for all the rest of these. And then for the rest of the code, fireball, frostbite. Frostbite. What's the next one? Fireball, frostbite, thunderstorm. Thunderstorm. D dot frostbite, frost power. Frost power, frostbite, frostbite, thunderstorm, frostbite, frost power, Fireball. There's one more. Water bolt. Water bolt. Oh my god. Reveal water power. Okay. Otherwise, we have to do the stupid longest subsequence or something. Is that what he said? And your spell journal. What is our spell journal? Okay, current spell journal is going to equal to spell journal read. Spell journal.read. I can't do this. Why can't I do this? Oh my gosh. Read. Oh, is it spell journal colon read? Yeah, read. So that's our current string, and then we need to do this with the spells string. So what is a spell string? Where's spell? Scroll name? Spell reveal scroll name? Oh. Yeah, reveal scroll name, and then we gotta do lowest common subsequence. Longest common sub is it what did he say? Longest common subsequence? Oh yeah, longest common. Okay. Alright, that's not hard. Let's just do like LCS per scroll. Yeah. Yeah, that's it. Let's create like a method called LCS. I can't create a method called LCS? That's so stupid. Okay. I guess I'll do it here. Okay, so we need like a integer dp cur dot size plus 1 scroll dot size plus 1. I'm gonna loop through cur size, loop through scroll size. Ah, crap. Why can't I do this? Oh. DP at what the hell was it? If they're the same character, wait, what was it? I forgot. It's like if it's the same character, we return it. In other words, I have to go to the previous plus 1. why don't we use vector vector? I don't know. Maybe this is fine. Oh my god. Okay, so think about it in terms of I don't I did this like twice already. I should be able to know this by mem heart. Yeah, it's like this. Okay, hold on. Oh my god. Okay, I'll just sign in. Alright, just to make this shut up. Oh my god, skip. Okay, thank you. Now shut up. Okay, yeah, so if the previous is equal to wait. Okay, I understand. Okay, I understand. Okay, I understand. Okay, so if the previous so if we're on the first carrier, we're not doing anything. It's just going to be dp at ij is going to equal to 0. Otherwise, if the current at the current string is equal to scroll at the jth string, then we do current at I, j is going to equal to current at I minus 1, j plus 1, not cur dp. I believe that's right. Otherwise, we're going to do dp at ij is going to equal to d max of dp of I minus 1j, dp of j, I and then j minus 1. Return dp at current dot size plus 1, dp dot scroll dot size plus 1. Should be correct. Yep, I minus j. The previous previous of plus 1. Okay. Okay, this should work. Well, we're failing some test cases. Time limit exceeded. Is one of the longest subsequence? Minus 1 j. J minus 1. My guy. This should be equal. This should be this. This should also be equal. Oh, J should be equal. Pretty sure this is right. No, that's right. Oh wait, no, it's J minus 1. If the previous is equal to... Okay. Okay, now it's right. Yeah. Okay, cool. We should think about the recurrence relation ourselves later. We're literally almost done with all the hard problems. Wait, are we done? No, we're not. Not done yet. Yeah. Bit arrays. You're given 4. Use them to create a sequence A with the following pseudocode. Okay. Calculate the number of distinct integers in sequence A. Distinct integer that denotes the number of distinct integers in sequence A. What? Is the mod afterwards or before the queue? Alright, I'll just do this really fast. N, S, and Q. What is A? Times by Q plus Q mod by 2 to the 31. I don't know. Oh, you could take the log base 2 on both sides. So you get like S is between 31 and what's log at 0? Log base of this. What's the opposite of modulo? Inverse mod? I don't know. I have no idea. I think that's enough live stream for today. Tomorrow I'll finish it up, but we're almost done. We just needed 2 more. But yeah. Hope you guys enjoy this live stream. Rate, comment, subscribe.